Today we're going to do a solubility activity to introduce us to solubility. So first, let's pose the question, is there a limit to how much salt can be dissolved in a specific amount of water at a specific temperature? So we're going to do a little experiment. First, we're going to take a little beaker, and I've changed it from 100 to 40 grams of water. So here is my beaker with 40 grams of water. And I'm going to add one little scoop of some salt into my beaker. And now I'm going to stir it until everything has dissolved. And so we know everything's dissolved if everything disappears into the solution, and it's because the positive ends of hydrogens in the water are connecting to the negative ions of the salt and pulling them away from the crystal. And then the negative ends of water, the oxygens, are hooking up with the cations in my salt and pulling them into the solution. So water essentially separates all the cations and the anions from each other in an ionic compound in order for them to dissolve. So a quick visual is where some salt was put in water, and here's the positive hydrogens attaching to the negative ion of salt and then pulling it away into the water. While over here, the negative ends of water hook up with the positive ion of salt and then pulls it into the water. And this is what's happening at the molecular level for dissolving. And as it pulls the ions away, that's when it disappears into the water. So now, what's the state of my solution? It's completely clear. You can't see anything at the bottom of that beaker, and that's because everything completely dissolved. So the state of this solution is nothing but liquid. So there's really nothing to draw here because everything dissolved into the beaker. Here's the question. Would you call this saturated or unsaturated? And the answer to that is it's unsaturated. Because saturated would mean that we dissolved the maximum possible. Unsaturated, we've dissolved less than the max. So that means that we could dissolve more since it's unsaturated. So now I'm going to move to the other side of my page, and we're going to add 2 more scoops of salt and then try to dissolve it. So here's 1 and 2. Okay, and I'll stir that up until all of it has dissolved. And you're going to notice that the solution starts to become a bit more foggy. And now that I've let the solution settle, I have stirred it and it has dissolved as much as it could possibly dissolve. And now there's actually an excess or extra salt settled to the bottom of the beaker because that's the salt that could not dissolve because the water has reached the maximum. The water's full. So now everything excess is sitting at the bottom. Kind of scoop it up so you can see. And I'll just drop that back in there. So what does it look like when you now have a saturated solution? We've dissolved the max. And look, there's some salt left at the bottom of that. So this is officially a saturated solution. We've dissolved the maximum possible. And so what that looks like in your beaker is there is solid salt settled out at the bottom. So we have excess solute settled out at the bottom of the beaker. And so that's the visible way to know that it is saturated. So I'm even going to add here, because this is important, it's visible excess solute. You can see that there's more all dissolved that could possibly be dissolved, and so we have this extra sitting at the bottom. Now let's answer the questions. How can you visibly know a solution is unsaturated? It's clear, which kind of gives you an idea that more can be dissolved, right? How can you visibly know it's saturated? There's visible solute settled out. So you can see visibly some solute sitting at the bottom of the container. Does it make a difference if the water is hot or cold for dissolving a solute? Yes, it does. If it's hot, you can dissolve more. So hot can dissolve more. The amount of water that we use to dissolve the solute, yes, more water, more can dissolve. Okay, and then number 5, is it possible to force the solution to dissolve more than its maximum at a given temperature? And the answer is yes, and there's a name for that. It's called supersaturated. Making a supersaturated solution is actually the process of how we make rock candy. So let's look at this little video clip about making rock candy. So first, they're going to pour 3 cups of sugar into a container, and then after they pour, they're going to add some water. They're going to stir it to dissolve as much water that can possibly be dissolved. Then after that, they're going to heat it in the microwave to increase how much can be dissolved. So once they've heated it in the microwave, now they can stir it to dissolve as much of that or to dissolve all of the rest. Okay? And then once they've gotten all the sugar dissolved, they're going to add a little bit of food coloring to make the rock candy a pretty color. Now, here's the really important part. They're going to move it to a jar, and they're going to take a string and dip it into the solution, and they're going to set that out to dry. And what that's going to do is allow some crystals to form on the string, so that after this solution in the beaker has cooled down, then they can insert the crystals and have somewhere for more crystals to grow. So this solution has to be cooled off to be supersaturated. And now that it is supersaturated, there are some crystals on this string, and so those crystals are now hitting the supersaturated crystals, and they're going to cause them to come out of the solution and do what's called recrystallize on the string itself. And so after this process is finished, you can see that the crystals have formed around the string, and then once they clean it up, we have rock candy. Now let's do our hand warmer demonstration. This is an instant reusable hand warmer, and to activate it, you flex or bend the metal disc and crystals will begin to form, and then you keep it insulated for prolonged heat. So right now let's take a look and describe what our solution currently looks like. It is clear, no visible solute. Okay, and then if we were to disturb it, let's see what happens to it. So we're going to flex the little disc that's inside, and what you'll notice once it flexes is recrystallization is occurring, where it is a supersaturated solution that has too much dissolved, and so when we disturb the excess that's dissolved, it comes back out of the solution in this process known as recrystallization. So to know, this is categorized as a supersaturated solution. And the way to tell a supersaturated solution is at first it's clear with no visible solute. When disturbed, recrystallization occurs. And that would only happen if your solution is supersaturated. And the reason the recrystallization occurs is because a supersaturated solution is unstable. So disturbing it caused recrystallization because it's an unstable solution. So that was a supersaturated solution. But what is it now? Because it's not supersaturated anymore once we disturbed it. So let's move our paper over to the right. So now the way to describe this is there's visible solute. So visible solute. Flexing the disc or doing anything to this will not cause any change, so it's stable, unlike our supersaturated solution. And so it has max amount dissolved with excess solute visible. And so since we can see visible solute, that's what makes this currently in a saturated state. So this is a saturated solution. When you can actually see the crystals inside, it's a saturated solution. All right, now let's move to the bottom left of our paper. Now we're going to heat some water and place our hand warmer into the hot water. And what this is going to do is it's going to allow the water that's inside the packet to begin to redissolve all of our recrystallized solute that's in there. So we're going to watch this over time and heat it to see what happens. Now everything has been dissolved. I'm going to give it 30 more seconds in the boiling water just to be certain. Now I've removed it, dried it off, and let's continue with our video lecture. So now we've taken it from the boiling water, we've heated it, we've redissolved all of the solute. This is now clear with no visible solute. However, this was the situation with our supersaturated solution earlier, if you look above. So how can we know whether or not this is supersaturated? And the way you can know is we can flex the disc just like we did before. And when we flex the disc, you're going to notice nothing happens. So nothing happens when disturbed, and so that makes this an unsaturated solution. And an unsaturated solution has no visible solute and nothing happens when you disturb it. And in order to get unsaturated, we had to heat the water so that it was able to dissolve more. However, because this is so warm still right now, I could probably even open it up and dissolve more, but we're not going to open it, obviously. So let's see what temperature this currently is at, because we know that heat was used to redissolve all of that solid. So I'll kind of jot that down here. Heated to redissolve solute. And you'll notice the temperature is rising pretty high there, and we can say it stopped at about 116. So now if I want to have a supersaturated solution, let's scoot over here to the right, we would have to cool it down. So notice that this one, because it's still at the high temperature, that when I flex the disc, it doesn't do anything. It all still remains dissolved, and that's because it's unsaturated, which is a stable solution, by the way. We did not put that a minute ago, but we could have. That is a stable solution. So if I want it to be supersaturated again, I'm going to have to cool it down. So this one currently is at about 76 degrees. And so you'll notice it was cooled down quite a bit from after I heated. And so this is now currently back in a state of being supersaturated. So cooling it down to make supersaturated again. And again, if we disturb it, we should get crystals to get recrystallization. Okay, so once you cool it, after cool, it is a supersaturated solution once again. And of course, we can prove it. Again, here's my cooled one, the one that's cooled off. It's at 76 degrees. And so now, when I disturb it, we get recrystallization. One more time. That's how you can tell a supersaturated solution from that is unsaturated, because if it's unsaturated, disturbing it would not do anything, right? Okay, so now that we've completed our hand warmer activity, let's work on the next page. So we can graph the solubility of a substance, and when you have a saturated solution, so this one has crystals inside of it, so it's saturated because there's visible solute that you can see with your eyes. That would be represented by the line on the graph. This is saturated. Then, if you have an unsaturated solution, it means that you could dissolve more. This is my hot one, so it's still unsaturated. So since I can dissolve more, it has less than the maximum dissolved, right? Because saturated equals the maximum dissolved. So unsaturated is going to be under the line. We could still dissolve some more, right? Depending on where you are, you can actually see exactly how much could you dissolve. And so this is less than the max. And so if we're above the line, then that's going to be our pouch that is cool and unstable, and so it would recrystallize if I bothered it, and that would be above the line. That's going to be supersaturated, which is more than the max. That's been dissolved. So you basically forced it to become saturated at this really high temperature. And then when we cooled it, so let's say I brought the solution up to 50 degrees, and then I went ahead and dissolved this much solute. I dissolved about 55 grams. Well then, let's say I cooled it down, but not before I dissolved all 55 grams. And so now, this is which way I'm going when I cool it off. I still have 55 grams dissolved, but if I bring it down to say 10 degrees, well, I have 55 grams dissolved at 10 degrees. I have way more in the solution than I should. And so if I were to disturb that solution, then this amount from here to here is how much would recrystallize, and then this is the amount that would stay dissolved. And then we would have a saturated solution because only 10 grams would be dissolved, but the rest of these grams would become visible solute. And so that's how we can represent what happened in our hand warmer demonstration on this graph. So for the record, this represents how much solute is dissolved in 100 grams of water. If we change the amount of water, that's going to change the amount that we can dissolve. So how many grams will make a saturated solution at 20 degrees? So here's 20 degrees. We go up to the line, and then we say that it's about, I would call that 15. So maybe it's about 16 or 17 grams. Let's just call it 16 grams of solute can be dissolved, and that would make it saturated at that temperature. What about at 40 degrees? Well, at 40 degrees, I can dissolve this much. So how much is that much? Let's bring it over here. That's about, I would call that 35. So I would say this is about, say, 32 or 33. Let's call it 32. All right, and then at 60 degrees, how much can we dissolve to make a saturated solution? And notice that's off of our graph, so that's something way up here. So we can just say it's definitely more than 60. We won't make a guess. More than 60 grams to be dissolved. Okay, so what happens as the temperature increases? The higher the temperature, the more you can dissolve. Now turn to the last page. We have the 3 categories, and down here is your phrase bank. Rewrite each phrase from down here underneath the category to which it belongs, and then unpause the video in order to check your answers. Here are the correct answers. I'll zoom in to each box for you. Unsaturated, less than the max is dissolved. Crystallization does not occur when dissolved. No visible solute in the solution results if the temperature of a saturated solution is increased or heated and it's under the solubility curve on a graph. If you have a saturated solution, the max amount of solutes dissolved, crystallization does not occur when disturbed, excess solutes settle to the bottom of the container. There's visible solute, I added this one, and it's on the solubility curve of a graph. And then a supersaturated solution has more than the max amount of dissolved. It's unstable, so when you disturb it, crystallization will occur. To begin with, there's no visible solute, and it results if a saturated solution is cooled above, and it's found above the solubility curve on a graph.